Lambda expression helps passing a function as an argument to another function, or we can consider lambda as a higher order function. To understand lambda, first let's create a situation which will be best suited for lambda. And to show that, I have a class called search, and inside the search I can have a method to find something. So I can declare public, let's say the return type is boolean, find user with age greater than 10. That's what we want to find out. And here we can pass a list of users age. Let's create a user class also. And user class can have private age, and we can have getter and a setter for age. So let's say this is the user object. So here we can pass a list of users, and I'm going to just import the package java.util.list. And here we're trying to find an age greater than 10 of the users. So what we can do is we can do for, and then we can have user in the users, and here we can do if user.age, calling the get age, is greater than 10, return true. This will be users. As soon as we find a user whose age is greater than 10, we return true, otherwise we return false. Very simple implementation. Now here this function is very specific to age greater than 10. If we want to have age greater than something else, we cannot do it. So for that we can change it, and we can add int age here, and here instead of 10 we can use the age. So now we got one level of flexibility that we can pass the age. Now instead of just comparing greater than, what if we want to check greater than equal to in some cases and less than or equal to in some other cases? So how do we do? Now we have to introduce another variable here, and you can see how this method will start getting complicated. So how do we not do that? How do we give this responsibility to someone else to decide what action to perform in the if condition? Well, we can do it easily. So for that we can create an interface, and we can name it as condition.java, and this is the interface condition. And this condition interface is going to have only one method, which is going to return boolean, and it will have check. And the check, of course, will need to take the object of user, because it's going to use the user to check condition on the user. So that's how we define. So if we do that, if you remember, we used anonymous class in the last video. So we can use the concept of anonymous class here. So now what we can do is, here instead of passing the age, we can have condition here, and here we can just check if condition dot check user and pass the user. Now this becomes much more reusable, and here we find user with age, instead of greater than we can say with age condition, some sort of condition. We don't know, the condition depends on the implementer. So at this point in time, if we go to here in the main, what we want to do is we want to call this method. So we can say search, and then we'll do search dot find user with condition. Now we have to pass a user list. So for that we can say of array list of user here, and then we can just run a simple for loop. And here we can do for user is equal to new user, and then user dot set age, and we can keep the count +1 as the age, and then we can do users dot add user, as simple as that. So this is going to add all the users into this. So now we'll have 10 users. So here we can pass users, and for the condition we want to pass an implementation of the interface. So here what we can do is we can use a anonymous class. So just like in my last video where I showed anonymous class, here we can use new condition and provide an implementation for the method. So here we can say public boolean check, that was our method, and the check takes the user object. And here we can do return user dot get age is equal to 5. Let's say we want to check if the user age is 5. That's all. That's pretty much it. That's all we have to do. Now here if we do, here we compile and then run this code, it would have returned true, but given that we are not printing this, we are not seeing anything. So let me just set this to a response value, and here we do system.out.println, and we print out the response here. Now let's again compile and run, and we can see true because we had an age of 5. But if I change this to 15 and compile and run, it's going to show false. This is just to show you that the logic is working as expected. So now you can see that we created anonymous class, and that can be used to pass as a parameter. But as you can understand, this also is a lot of code, and this is where exactly Lambda comes in handy, because all we are actually trying to do is just to execute this function. This is only our requirement. So all we wanted to do is actually to just do this. So what if we can do this somehow? And this is where we can use Lambda. So here what we can do is we can use the Lambda signature. So we can say user, and then we can give this arrow, and then we can define the exact thing. Now this is how the implementation that we had with anonymous class can simply be converted into a Lambda. And the reason we are able to do that, because the condition is a functional interface, and a functional interface is any interface that contains only one abstract method, and that's what our interface was. Because the functional interface contains only one method, we can omit the entire class implementation and just keep the function. And to do that, instead of using the anonymous class expression, we can use the Lambda expression, and this is exactly what we did. Now if we go ahead, compile and run this, we should see the exact same response. And now let's change it back to 5 and run, and we should see true. So this is how easily we can use Lambda expressions in Java. Now here the Lambda expression is only limited to a user object. What if we want to make it generic? Well, we can do that also. So for that, all we have to do is we have to make this class as generic. And here, instead of user, we just have to take t. So if we do that, and then we have to go to search.java, and here we have to just have to say condition of user. Now if we want to make even this one as generic, we can still do that. We can use t here, and here we can make this class also as generic. And of course here it has to be a list of t, and this is going to be also t. So we'll run through t, and then here now for the search object, here we can use it as user, and that's it. Now we have a generic interface which implements a functional interface with one abstract method with a generic type. Then we implemented search with again a generic type, and it doesn't have to be called users anymore because it can be anything. And then in the hello world.java, here we are creating search as a user type and doing all these things. Here instead of user, we can also use search as an integer, and here we can say integer user, and we can say user is equal to this one. And here instead of this, we can just declare a integer array list, and we can just set the count here. That's all. And now everything is converted to integer, and this is also going to work as expected, and it can run and show it. So as you can see, we started with a normal implementation, then converted into using an anonymous class, then converted to use a lambda expression, and then finally we're using lambda expression with a generic type. So that is all I wanted to cover for today's video. If you like this video, please give it a thumbs up. And if you are new to this channel and you think you are getting value out of this channel, please subscribe to the channel. And thanks so much for watching this video.